All right, so in the next one, we want to find the energy of an electron around a hydrogen atom. And this is a formula that's got something to do with basically all of our remaining questions. Very, very important. It has this special constant with it. This is slightly rounded from where you often see it, but negative 13.6 electron volts. Then we've got z squared over n squared. So technically this is useful for hydrogen or hydrogen-like atoms and is reasonably accurate for a lot of stuff. Um, N just has to do with the particular state of the electron. So it can be, 1, 2, 3, 4, 5, 6, 7. Um, for different excited states, it basically means electrons that have taken energy and jumped up to a higher state. Then Z is the number of protons. So if you think about where hydrogen is on the periodic table, it's in the top left-hand corner, very first element. It's the number one because it has one proton. So that's what's going to go into here. That's an important concept because the way that the protons and electrons try to attract each other, having more protons in there is going to change the way the energy works. Nice thing about hydrogen, and especially about it being n equals 1, is that we're plugging ones into both of these numbers and they basically just get absorbed. So I'm going to show the work here, even though it's going to seem a little bit silly, at least on this question. We're going to have 1 squared, and on the bottom we're again going to have 1 squared. So obviously, or at least I hope it's obvious, we get negative 13.6 electron volts. Now it's negative. You get negative energies when you're dealing with something that's basically going where it wants to go compared to going where it doesn't want to go. And we've seen different types of potential and kinetic energies before. But this negative sign sort of resolves itself a little bit further down when we start doing work. So it feels a little awkward to have negative answers here, but it makes sense. I would recommend highly, because this number can be randomized, it's not always going to be a 1, that you go ahead and find um, each of the different values. So we call this, say, E1. Um, find E2, E3, E4, E5, E6. All of the top numbers are going to be 1 because these are all hydrogen. But the bottom number, you can plug in and find the different values for energies, and it'll allow you to take some shortcuts and some lower down questions.